This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Sieberg. Good morning and a happy new year to you and to all our listeners. Robert.
Yeah, thank you. Happy New Year to you too, Peter. It's a pleasure to talk to you. We have a lot of interesting episodes planned this year. Let's start.
Did you see the amazing result we had with Festo?
Oh,
I
wow.
sent you this morning.
Yeah.
On YouTube. Over 10,000 new listeners. That was amazing.
It was really amazing. I got a lot of emails from my robotics colleagues about Festo and the ideas of Festo. It was very, very interesting. I'm looking forward to the next episodes with you. It's very, very interesting.
So welcome to you, YouTube listeners. I'm not sure what that means. You know a lot better this market, Robert. I mean, we started through Podigy, and then we have what you call the podcast catchers, I believe. So it's like Apple and Spotify and the other ones. But we've always been doing YouTube, I believe, but maybe not so actively. And then we swapped from German to English. So now we're welcoming all these people from around the world who are more regular YouTube users, I assume, or...
Yeah, sure. We have more guys who said, I want to get informed when a new episode comes out. So we are looking forward to hear from you. You can write us an email, robert@aipod.de or peter@aipod.de.
Can they leave a comment as well?
They can leave a comment also,
okay.
yeah.
Okay, good. And are we going to be doing video at some point in time? Or are we going to stick to the...
Peter.
No,
I'm
I agree.
happy that your microphone is working now.
Yeah, I agree. We're going to, for the moment, we're going to stick to radio kind of podcast.
Yeah.
Very good. Let's start.
I have one question, Peter. What will be the most important topic on industrial AI in 2023?
The most important topic of the day we're going to be talking about today. And is that going to be the one as well? That is one. So ChatGPT, right? Not from the beginning 100% plus. Most certainly not. There's things we can do with it, things we cannot do with it. That's number one. So coming out of that, maybe then is the most important thing for the year or for the next couple of years is to work on reasoning-based prompt solutions. That's maybe the one. And or, we started looking at models, a year or two ago, and I was going to ask you anyway, there's a conference or a happening that we still need to talk about if we're going to be going there in an industrial environment. Well, what is the role of AI-based models? That's still the two things that I think about. What are you thinking about?
I think about generative AI.
Okay, yeah. Sure.
Using these technology to build new products, new solutions. It was very interesting what we heard from Jan and from Festo about generative AI. I think there's a huge potential on this topic too.
I agree. I actually had one or two on the topic of generative in this morning's calendar, but decided that's what we're going to be doing right now, to concentrate on ChatGPT. But I completely agree. So if we look at it, DALL-E is, the sister product of ChatGPT. So whatever is generative, maybe not sure where are we splitting them? Is maybe it is right. Maybe ChatGPT is a different category from, we'll come to that in a moment, actually. But we're looking into the same direction, I guess, yeah.
I don't know if you recognize, because OpenAI also offers now 3D models on DALL-E.
Yeah, I saw that, yeah. Amazing.
That's very interesting, but that's very important for the industry.
That's amazing, yeah. So maybe we talk about that later, or also one of the next episodes, because then you now talk about a guy who, built the first wireframe models, right? That's probably 30, 35, 40. Can I really say that I'm so old, years ago? That's really amazing. That was computer added, in my case, architectural design. And now, as you say, we come to the point whereby, a designer or the engineer, or the more technical oriented person is then going to say, okay, show me what I can do Dan, and by the way, now combine it and make sure that it makes sense from a technical perspective as well, right? And that's amazing, of course, right? Yeah.
I'm very impressed by that, yeah. And so I think it's very important. It could be the most important topic for industry.
Let's see. Yeah, let's see. We'll check again at the end of the year if our thoughts were right, or if there's going to be another, amazing technology coming in from the side that is even going to be more mind-blowing than what we're talking about today.
But you mentioned ChatGPT is different to DALL-E. What is the difference?
Well, let me put it this way, if I may. So for whatever reason, I came up with the good, the bad, and the ugly. And then I thought, what is that all about? What is that quote about? Do you recall what the good, the bad, and the ugly is?
No.
You don't. It's a movie. It's probably, you may have seen it in, I look back, it's from 1966. It's a spaghetti Western. It's one of it's the typical, of course, with Ennio, what's his name? Morricone, right? That's the
Morricone.
He makes the music.
The music,
What's his name? He's now mayor in somewhere in the United States there on the coast. What's his name? The guy who does the number one actor doing the spaghetti westerns. I forgot. So we're not talking about that today. So what I'm talking about, the good, the bad, and the big business. So concentrating first on the good. Sure. I mean, the one and only thing, and really everybody and everywhere, talking about these days, you cannot open LinkedIn, is what I concentrate on. It's amazing, right? Everybody and their mother and their father sharing thousands ways to, number one, to increase your efficiency. That's what I would call the category, efficiency improvement, something like that, right? I haven't seen a category kind of definition yet. So it looks as though with, one single approach, the long talked about, and that was RPA. We called it robotic process automation. Maybe that's the name of the category. It landed on Earth. I mean, I talked about it, and with your support, the book 2 years ago, and it was at that time RPA. And I said, algorithms taking over from humans, our so-called, what I call zero value add. Humans, wherever we work, right? Typically more in administrative, but also everywhere else. We look for data somewhere in an office environment, then we copy it and we paste it into a different format. Right, that's what we do all day, from morning till afternoon. Many of us, not all at the same level, and then we pass it on to the next stage or instance, and that was the idea we said is going to be taken over by. And now there's ChatGPT, which is, of course, not just doing this very easy thing. But let me just share for those of you listeners that maybe have been, let's say, spending the holidays on a deserted island somewhere, with no internet connections. I'm just going to call out 10 or 15, and then we make a break and then we talk about it. And this is still about I would say, the positive side of the ChatGPT. And then later on, we come to the negative, the ugly. There is a very ugly face to ChatGPT as well.
Hey guys, I have to interrupt Peter for a moment because we have an important information for you. You have to attend the Siemens AI with Purpose Summit. When? On 16 and 17 May 23. Where? In Munich. Festo, Bosch, OPC Foundation, Arburg, IoT Analytics, and many other industrial users will be there. If you want to be there, we have 5 tickets. First come, first serve. Write us a message or an email, robert@aipod.de or peter@aipod.de or a LinkedIn message or what else. Thank you very much. And now back to Peter.
There is a very ugly face to ChatGPT as well. Think about ask ChatGPT to create an advertising campaign. I've been in that business. You are still kind of in that business. Ask it to come up with powerful, meaningful rapper lyrics. Maybe you're a rapper. Ask it to do it for you. Ask it to act as a user interface developer. Ask it to develop a new product. You asked me a couple of minutes ago, what is the biggest thing? And you said generative AI. Yeah, sure. And you can go to a direct solution or ask ChatGPT to design, to come up with ideas for the new product or service for you. You're a cybersecurity specialist. Ask it, to come up with ideas for you. ask it to be a doctor, to come up with creative treatments. And of course, did I forget to mention your listener job title? No, there's so many more, right? So don't be sad, dear listener. If you did not hear your profession mentioned, I'm completely convinced that as far as this side, the efficiency improvement is concerned, ChatGPT in its category, not only this one, I think there's going to be hundreds of this kind of solutions, especially, and we come to that at the end, because it's from OpenAI. As the organization still wants to be open, everybody should be able to use it. So I would suggest, before we then get to the bad side, let's chat about this a little bit. ChatGPT.
ChatGPT. Now, once again, what do you think is the difference between DALL-E and ChatGPT? Is it both generative AI, or what is the difference?
I mean, DALL-E is graphics, image based, whereas ChatGPT is a prompter. So you ask ChatGPT to do things for you, to come up with ideas which are then written. So it's text based. And DALL-E and all the other ones, the Midjourney and the Stable Diffusion. I think I've been looking at that one, and again, because I didn't find the other one, and I was very impressed as well. I studied architecture, as I have said. I studied computer design architecture, and there was one job we had to do is build a home on the North Sea, Netherlands side. And I had this idea that you would look over the dunes, over the sea, and then on the backside, you would be behind the dunes, right? And that's what I gave in. And it came up with images. I was blown away. I was really blown away. And this is exactly what I mentioned before. Of course, I'm not only talking 30, 40 years ago, people who do this work today, architects as an example, but anybody listening in the industrial environment. So I think the DALL-E type of creative, I think I wouldn't limit it to, but it's especially known for whatever imagery. And you can, of course, do the same thing with music. We've had our friend doing this with
Tristan, yes.
Yeah, with Bach music or other kind of music before. That's it. And I think ChatGPT is like a prompter. And what we just discussed is it to help it for improving efficiency / also you can use it. It might become a front end to many other things, because you can ask it to generate the optimized, again, efficiency improvement verbiage for Midjourney or for DALL-E or for Stable Diffusion. Because, again, already in the meantime of 2 months, there are certain people who have become the specialist in how to exactly write these prompts for the different graphic imagery, solutions. And then you ask DALL-E to do that for you, and does it in a perfect way, better than you can ever do it.
I read an article. Now we come to the bad side, maybe, of ChatGPT.
Yeah.
It was a very interesting article from Gary Marcus. I think most of our listeners know Gary. And I want to comment on ChatGPT. I will put the article into the show notes. Everybody can read it. It was in the New York Times. You get better approximations to the sound of language, to the sequence of word, but we are not actually making that much progress on truth.
Yeah, completely true. And that's very diplomatic.
Yeah.
I want to be careful, because we are a very professional podcast, and I don't want to be too direct. Now, Dutch people are very, very direct. So, but to put it more, if I use the word nonsensical, which is a diplomatic word for nonsense, I believe, and that word comes from OpenAI, right? They say it themselves. So we can use it here. So the very bad, the very, very ugly side of ChatGPT is that if you use it as a prompter, you ask it knowledge, you ask information about this world around us, it will come with complete nonsense. And it does so in a very authoritative way. That's the bad thing. You read it and you think, oh, wow, that's amazing. Now, but what it says, the contents, may be correct, but many times is complete and utter nonsense. And that is, of course, very, very dangerous. And that is and Gary is, as you said, He's probably the most well-known. I did ask Gary if he would be interested to be on our podcast. He hasn't answered yet. Gary, if you're listening, if one of your colleagues at your New York University is listening, we're very interested to have you on the show, of course. So what can I say? I must almost say, frustrated. And we come to Mr. Altman, CEO of OpenAI, at the end. But I'm very frustrated. I mean, how can you be so irresponsible? I must say, to put such a half-baked, nonsense-generating tool for consumers on the market. And that is the thing. We had a quick talk about it, I believe, at the end of the year. And then there was this group of young people, 25 years old. They were completely impressed, and that's good. But the first category of the efficiency improvement. But at the same time, I felt that they had no clue about the nonsensical part of the ChatGPT, providing answers, and that is a serious problem. So when I at the beginning suggested that the most important thing that we should be doing now, if that's going to be happening, many AI professionals are working on it, that we need to come to a reasoning base, a graph, a symbolic base, reason-based, a prompt solution, of which we then know is going to be giving, answers that at least have a relationship to our world. Many people are working on it. How far we haven't come with a solution there yet, but it's very, very dangerous. And I would almost say it's imperative that this ugly side is going to be, I don't know, improved, stopped. Who am I? It's out there, right? But at least I believe it needs to become regulated.
What else do we have?
Yeah, okay, but I do want to, so the final thing is then the close off is then the big business thing. It's just like
Microsoft announced some things.
Is it Microsoft? Well, I think that OpenAI themselves, they are looking for possibly, I think it's a Wall Street Journal article there, and they have entered talks to sell shares. And then there was somewhere this, 29 billion. So the question is OpenAI really worth 29 billion? And it's very much relates to your opening question. And what is the biggest thing in industrial? Then, of course, that's the next thing in AI that we're looking at. And it is, of course, today's ChatGPT, with all the plus and all the negative things that we just talked about. And then the question is, other companies, in addition to Microsoft. But we shouldn't forget, I think also Amazon, but also Google and a couple of other ones are supporting the OpenAI organization. Of course, Microsoft is number one, and they have been set to be including already ChatGPT into their Bing search. So it's their way, it's being set and being rumored that they can, come apart with Google. So that's maybe the close off of this part of the conversation. What do you think? Are they worth 29 billion or 290 billion? I don't know. What do you think?
It's all about expectations you have on this technology. And we both know that in our industrial companies, industrial sectors, it would take a long time to find solutions where you use ChatGPT. I think that we will see it not tomorrow, next week, or next month. It takes a long time to do it.
Sure, but maybe that's my close-off thought then on this one. And I shared it before. I believe that was it maybe 6 months ago. There was that the specific? I forgot the name. In GitHub, there's a tool that helps the software coders. And at that time, I shared that on LinkedIn, and I triggered kind of a shit storm, right? Who do I believe that's ever going to happen? And then we've talked about this before, and now I must say, and of course, because it's always the same that the majority of the people who are around technologies like OpenAI, ChatGPT are the software developers. They are the first people to know about it because they have developed it, right? So they talk about it in their own circles of friends and community, etc. But now in the meantime, you see there's nothing of a shitstorm. I mean, certain people are afraid, whatever. I don't think there's no reason to be afraid. Just that is the important thing, that we do talk about it, and also for our listeners in industry. And even if the first products are only going to come out in 2 years, that's, but would you certain, the listeners, you need to be looking into it. And that's what the software coders are saying today. They become sometimes, some of them say, I become 10 times more efficient. You think about what that means. Somebody's asking you for a quote. And yesterday you said, okay, give me $10,000. I'm going to doing A, B, C, D, E. And the next time, this is only going to be worth, $1,000 or the other way around. You can do 10 times as many things. So that is something we need to think about on the positive side and on the negative side. Let's make sure that not only you and I, that's what we're doing, right? Is this that we are going to be, telling the world what ChatGPT, what the different categories, I would say, of these software tools are capable, and that we tell the public, and I believe still the majority of our listeners are professionals, but even if not so, you're very, very, very welcome to listen in. Also, if you're a consumer, not directly using the technology.
Professionals are also consumers, yeah.
At the same time, sure.
Yeah.
Their dads and their mamas and their friends and whatever they live, they live on this earth.
Yeah.
And please let us know, let Robert and me know what you think we should be doing. But I believe it's very, very important that we also inform the world of its potential danger in the category of the prompting.
What else do we have? The first week is always very quiet, but today there was an announcement, I think very interesting announcement concerning our friend Sepp Hochreiter, because there's a new Alice program, and Johannes Kepler University is a spearheads AI molecular research in Europe. And it's coordinated by Sepp and together with Oxford, Cambridge, Zurich, Berlin Charité, and in cooperation with AstraZeneca, and they will share experience and even computer code. So Sepp is focusing on research, or his group is focusing on research on AI molecular research in Europe. That's very interesting, I think.
Okay. I did read an article from Sepp as well. He was at, what was that? Is it called Future AT or something? But I did read about more general about your AI in Europe for those listeners, but not only Europe in this case, because I think bottom line, what came out was European universities, they attract a lot of people with bachelors from Eastern and Asian countries. And then many of those, after then they've done their master or even their PhD in Europe, many of them then move on, number one, to, what do you think?
To the big tech companies?
Yes. In what country?
USA?
Yeah, exactly. Yeah. So that was the main point. I thought it was very interesting, right? So we are kind of a through country, right? We attract from the Eastern market many people with base education. We attract them with their bachelor, for example. Then they do a couple of years, 4, 5, 6, 7 years, master, PhD. And then many of them, which is sad, of course, but we've heard that from Sepp as well. Many of them, not only, but many of them do move on to, as you said, the big tech companies in the United States, or may stay here, but many of them do go to the United States to their head offices.
Yeah, I read that also on Twitter. There was a discussion about that topic, that we lose our PhDs and what we can do in this topic. Yeah.
Right.
Let's start with the main part. We have a very special guest, Patrick van der Smagt from Volkswagen. It was a pleasure to talk to him. Peter, thank you very much for the discussion with you about ChatGPT. I think it was not our last discussion about ChatGPT, but I hope that in the next few weeks you go to holidays and we won't talk about ChatGPT.
Yeah, that I will be spending. I actually will be spending time on. It's actually an island. You're right, but normally, as things go these days, it's almost like one criteria is that you check for connectivity, right? So, yeah, I agree, and I do hope that those listeners that have come so far now and say, "Oh, what is that all about?" and we could do nothing. Do not believe that, please. I mean, it's like on the two sides, right? Don't think that this is so far away from my job. We've been saying all the time, all jobs are going to be changed. And what we're seeing here is such a big confirmation, one side and the other side. Please join us in making sure that the world knows that the prompt business side of the ChatGPT and other ones is a very, very dangerous tool that we need to be very, very careful with applying.
Thank you, and enjoy the main part.
Yep. Thank you, Robert. Have a good day. And also our listeners have a good day and talk to you next week.
We have a very special guest today, Professor Patrick van der Smagt, Director of AI Research at Volkswagen. Hello, Patrick.
Patrick is more correct than Patrick. Thank you very much. Good morning.
Okay, but the pronunciation of your last name was correct now.
That was quite good, yes.
Yeah. So you're from the Netherlands. What a Dutch guy is doing at Volkswagen?
Well, first of all, I'm not the only one.
Okay.
I've been living in Germany for quite a while, over 20 years now. And why not Volkswagen, right? I've been actually in research all of my life. So when I moved to Germany, I first joined DLR, the German Aerospace Center in Oberpfaffenhofen, close to Munich, and stayed there for a very long time, enjoying my research there and so on. But then gradually moved more in the direction of research. So I went to Technical University of Munich, stayed there for a few years, and then got asked by Volkswagen to build up a research lab, a fundamental research lab on machine learning.
And you have two email addresses. One leads to Volkswagen and the other leads to argmax.ai, correct?
I think I've got 10 email addresses.
Okay.
But those are the main ones I use professionally. I've got two other professional ones.
Why don't you briefly explain argmax.ai to us and what you do there and how Volkswagen benefits from it?
So my lab, and I've called it ArcMax when I was in Volkswagen, my lab focuses on machine learning research. And machine learning is a branch of science, if you want, that looks into exploiting relationships between data and creating some kind of explanation for it. Explanation is a popular term. I would normally say a model for it, but I would maybe more accurately say a generative explanation, meaning that I can have a short form of capturing those data, what they express, and also use that short form to recognize new data, but also generate new data that is similar to the other one, to the ones I've learned from. And that's something which is extremely mathematical in its nature. So that's probability theory, which is your main tool there. But it's also extremely computer sciencey. So you do not only need the probability theory and the mathematics there, but you also need the software tools to make that compute. And once you have those two things, then you have some kind of tool with which you can play with these data, right? And having a large data set is nice, but it's very inconvenient because you can't search in it and you can't use it. So you have to make that in this compact form with which you can compute. And then you can do something. Now, you can do that in a university, which is absolutely perfectly okay. But what is very difficult in a university or any research environment which is publicly funded is using those things for some real application. And a real application with that, I mean, well, it can be something in production. It can be also something in the medical field. It can be something to, explain neutrino stars or anything like that. That doesn't really matter. But to advance, let me say, our society and our environment in some way which we like. And so the nice thing of machine learning is that the distance between the theory and the application is relatively short compared to most other sciences that I know of.
What approaches in the field of machine learning are you looking at Volkswagen? You mentioned production, and then we have this huge topic, autonomous driving.
Nothing in that direction. What we're looking at is time series modeling and prediction, right? So I have a stream of data and I try to understand, in quotes, right? So model that stream of data and then make predictions of what will happen in the future. So that's it. It's very simple. And that has, I think, the most wide field of applicability that you can think of, because that is exactly what biological systems like ourselves are doing. If you're walking outside or you're cycling outside and you try to reach your goal, what your cortex is doing all the time is taking in these sensory impulses, using those to predict what's going to happen in the next few seconds, and use that prediction to make then an optimal plan in order to survive in the most basic thing, but in order to get somewhere fast and safe and what have you. And now this principle of getting in a sequence of data from your vision sensor, from your auditory sensor, from your olfactory sensors, from your tactile sensors, and using those to predict what will happen in the future allows you to make optimal decisions. Now, I can take that principle and I could, in theory, put it in an autonomous car if you would want to do that. That's absolutely not my field. But you can also do that in, for instance, optimizing production, because I want to save energy in some part of my production process, in my robot movement, for instance, because I know what's going to happen in the next few seconds. So I can now take more optimized decision on what to do. And those things work.
So you are doing a basic research, or what is it?
Yes, we do the basic research, and then we take that basic research. So the research we do is not directly guided by any applications. So it's not that somebody comes with an application to us and then we say, well, okay, let's look into that and see what research is. We turn it around. We are experts in these latent state space models, as I would call them as a technical term. So these time predicting models, neural network based models. And then we also have collaborate with other departments in Volkswagen Group to bring those to applications in the group, but also applications outside of Volkswagen. We're not xenophobic there.
So when you scan the landscape of machine learning, what are you looking for at the moment? Which paradigms of machine learning are interesting?
This is an extremely broad question. There's currently, of course, a huge interest in these large generative models, right? Your GPT and all of those related models.
What's your opinion on that?
It's interesting, it's fascinating, and I think it's extremely important that we understand and deploy those models correctly, right? I mean, if those things work so nicely nowadays that people immediately start abusing them for things where they are not very useful, like in question and answer system and so on and so forth, they're extremely good in generating images or videos or music or text or any of those things that baffle our mind, but do not necessarily have the causality that we're looking for. So it's a great tool, and I'm happy they're there, but you should know how to use them. It's still a tool.
Patrick, can I ask you maybe to clarify for our listeners and for us as well? And I've got a thought there, but if you could maybe confirm. So you concentrate on time series. So that's one group of one approach, let's say. Now then we've got the large language models, and they have a very structural, different way of dealing with data, looking into the data, finding patterns. From my perspective, the large language models mean sometimes being called stochastic parrots, always looking for the next word. Isn't that a completely structurally different approach from what you typically do with time series prediction?
Yeah, up to a certain level, yes, but there are also quite some similarities, right? I mean, if you derogatory say it's just a stochastic machine, well, what is our brain then? I'm not so 100% sure where the difference, what our cortex does, and what these models do lie. It's certainly not identical, but where is the difference? I wouldn't dare to answer that straight away. The kind of problems that my lab is looking into are more related to the physical world. So if I'm looking into a machine or a robot moving, then these machines typically have some physical characteristics, and those are well described by Newtonian physics, for instance, right? And that allows you, if you understand a bit of those physics or know a bit of those physics of those systems, then it's quite easy or easier to predict the future. And language is similar in that way, that there is also some kind of structure, but it's of course totally different, and you need a different way of describing it than from a physical system moving, right? So we have decidedly gone a different direction than many other people in machine learning go. So reinforcement learning, it's very typical to learn everything about your system just from observing it. But what we do is we try to combine your known physics. So if I'm looking at a robot arm moving, for instance, that robot arm has a very accurate description in terms of a number of simple equations that have been used in robotics for the last 50 years that you can use. Now, many people in machine learning then say, well, yeah, that's nice, but I can also learn it. Yeah, you can learn it, but it's not very efficient to learn that if you already have those. So what we explicitly look at is how can you combine existing knowledge of physical systems with machine learning in order to get the most accurate and long-term prediction of how a specific machine moves. And that also allows you in explainability of those models, right? Because once I do that, then I can say, well, yeah, all right, that there is this black box component neural network in there, and I've got 10 of those. But with each of these, I can put the equations of the physics of my system in and use that to explain what my neural network is actually learning. And that works nicely.
And an understanding of the physical word physics is one way. That is the area I understand you're concentrating on. And I'm not sure I want to reopen this box, but when we had Sepp Hochreiter, I believe you know him, Jürgen Schmidhuber with us, and we talked about the original symbolic 1950s, 60s, 70s maybe, and we got into an AI winter, and then came the sub-symbolic, more the machine learning. And nowadays, so Zeb says, he is looking at bringing the two worlds together again. And that's my feeling of, applying knowledge of the world to machine learning. Jürgen said he has never made that difference, right? He doesn't care. He never made an explicit split between the two. So that would be my feeling exactly, because I come out of the world of the time series as well in production, that is exactly lacking today with these large language models, that if we would be able to provide them with knowledge in one way or the other, the symbolic knowledge, that they would then maybe, start giving us more times realistic answers that, have a meaning to us and not sometimes complete nonsense.
You're absolutely right. And yes, those models are extremely valuable and powerful, but you have to be extremely careful interpreting and using what comes out of them, because you just have no idea, right, what they generate and why that is generated in that way, and you can't steer it, and I think that's the most challenging with these large complex models, is that there's no way of steering them, and also no way of repairing them if they make mistakes. So yeah, fascinating, but we still have to learn how to embed those in our daily work.
Yeah, well, that's the thought I would have as well. But then I'm not as deep into it as you are. We talked about it before, Robert. I had this group of young people who were finishing, a course I gave them. They were completely impressed by what, for example, the ChatGPT was doing for them. They told him, build this website, and 10 seconds later the website was ready, for which maybe until then they had used half an hour. And when I brought up this discussion of, not always is it giving you a correct answer in as, what is the truth, who knows what the truth is, but sometimes it's so obviously blatantly wrong, and even OpenAI says so specifically. So that is a big danger, I believe. So what can I suggest? Maybe they should look at, the kind of work then that you do, for example, Patrick, bringing in your case, it's physics, but of course, then the physical world is only one part of, or is it? Maybe that would be an approach, combining those two worlds.
Yeah. It's only one part of it, but as you also said, right? I mean, SAP is indeed also in that field. That combination of machine learning and computational models, existing engineered models where we have them, is of course the best way to go, as long as you can do that. And I find it wonderful that this is possible nowadays, and that we can use that to not only get more explainable or more understandable models, but also have models that work much better, learn much faster than years ago. I mean, we can now learn a model in a few minutes to control a drone or a robot arm and things like that. Absolutely unthinkable 10, 20 years ago.
We talk about these big foundation models. Why there's no such thing from the automotive industry, a big foundation model on automotive?
What do you want to do with that?
I don't know. Is there an idea to put ideas, how to use a factory to build a foundation model from the product line to optimize product lines? Is it an opportunity to do that?
No, you're now a bit looking at using a big hammer to just randomly hit about you, and I wouldn't do that. No. So these foundation models, I hate the word, but let's play with that because people use that.
Why do you hate that word?
Because it doesn't say anything, and it's like deep learning, also such a term, which is just popularizing things that shouldn't be.
Maybe large language models is the other term.
As much, it's better, at least, yeah. I would say currently large, because 2 years from now, they're not large anymore.
Right.
Anyway, back to the topic. These are all in the realm of end-to-end learning, right? You try to represent a complete problem from the beginning to the end, which you very much understand in parts, into one big monolithic model. And yeah, you get something. And then what? Right? Because this system gives me a solution which I cannot interpret, which I cannot, the quality of which I cannot quantify. So I don't know how good my result is. I don't know how to improve on it. I don't know if there is a better, simpler solution around the corner. As nice as it is, but an answer without quality is not better than no answer at all, I think. So I wouldn't know what to gain from that. And production is a beast, right? You know that as well.
Yeah, sure. But there are ideas of selling models. For example, if you have a special machine and you can sell these models from a machine, do you think a market will be increased to sell AI models to the industry?
Of course, that's already happening everywhere, isn't it?
I'm not sure if it's already there because the machine building companies are not very focusing on selling models.
No, but on purchasing them, right?
Yeah.
And that's a business case that is already being played with by Bosch and Siemens, for instance.
Yeah, but it's a big ones. But is it a possibility also for the mid-sized company to sell models that optimize your production?
That's difficult. It's a difficult market to get into, because if you look at machines that are used in production, for instance, those are typically being built by the larger companies such as Siemens and Bosch, or the robot manufacturers, right? And they usually sell their systems in a closed setup where they even own the data that comes out of the machine, even though you sell the machine to some production company. But often they retain the rights to the data that their machine creates. And let's be happy with the Data Act that the Commission has put forth to address that problem. But that means that it is a closed system, and as a small, medium enterprise, you do not have a very good chance of breaking those monopolies. So that's going to be hard. And then again, also the expertise in people who do this kind of machine learning at this level, it's much better than it was 10 years ago, but still the salaries that those people earn is higher than you will find in the competitive, the SMEs that you have in Germany, for instance. So it's not easy to hire somebody there and give them all the benefits that those people can get elsewhere.
So AI models are something for the big players.
Yeah, currently it looks like that.
Patrick, I had kind of prepared. I was going to ask you a little bit about autonomous driving. You say you're not a specialist, but the only question then, and then you don't have to answer. But my understanding would be, as you explained, that driving is one way of, as you said, we walk around, we drink a cup of coffee, we do all these things, and we generate time series all the time, right? Not only in factories, but all around us, basically. And my question then is, at least up until the point of, isn't basically the way that the world, including Volkswagen, I guess, is looking at solving, autonomous driving towards level 4. Isn't that basically also a time series use case?
Sure, the problem is in principle the same. But now if you get into autonomous driving, then the technical question is certainly not the only one to be answered.
Yeah, okay.
Right? I mean, I can easily, with the models that we actually we have something like that running for different, but I can get you your 95% accuracy, right? But you wouldn't get into that car.
No, that is the answer that I was going to ask you. And I still, and maybe then we only chat about it, very shortly still, because here we go. 3 years ago, Robert and I did this podcast with former Professor Dickmans. Not sure that you have known him at the University of the Armed Forces here in Munich in Neubiberg. So, and I think it's fair to say that he in the 80s, 90s with his team basically, solved autonomous driving in cooperation with Mercedes, et cetera, et cetera, et cetera. Drove to Denmark on the French, on the Paris periphery, and here we are, 30 years later. 10 to 20 generations, I don't know, of new hardware and software. And now I believe your answer is then going to be, okay, Professor Dickmans and his team came to whatever, 80, 90%. And your answer would be then, it's so difficult to move towards the 100%. Is that the problem that the world is still dealing with?
Well, first of all, he did level 3, right? What we call level 3 now. So on the Autobahn or in structured environments. And that is already out there, right? You can purchase that from Mercedes now, for instance. And a few others. I think Audi had something like that a few years ago as well. So I would, for that level, say, well, it's more or less solved. Now, anything that you see in an urban environment for autonomous driving, that is for me a totally different situation, because that would be the first time ever where we use a machine at eye level. So you engage with an autonomous car on the street as if it were another person, right? And I know of no other system that we have ever developed as mankind, where you use a machine not as a tool but as an equal. I don't know if you know of any examples, but I don't. Right? So that's for me principled quite different, and it's a wonderful idea to play with, but I also understand why nobody dares to put that on the street in a serious way, because it's just not there. And it doesn't mean it can't work. I certainly believe that it could work. But, since I joined Volkswagen, which was in 2016, I've heard autonomous driving being on the street within 3 years. And I've heard that like 4 or 5 times. Heard it last year again, or this year that it would be on the street in 2025. I don't believe that. When I was at DLR, I heard everybody will have a robot at home within 5 years. And I've heard that like every 2 years over there. And it's still not there.
We mentioned new paradigms of machine learning at the beginning. I want to come back to this point. Then we switch to ChatGPT. What new paradigms do you see?
Well, so the major difference, I've been doing machine learning since, we called it neural networks back then. It's since the mid-1980s, right? Before my master thesis, I worked on neural networks for character recognition, and for my PhD thesis, I started on robotics and stuff like that. And the major difference between back then and right now is the scaling. Meaning that all of those things that we wanted to do back then, even back then we talked about, well, if I get a neural network and have 1 million neurons rather than just these 100 that we use now, it might probably work. And then, of course, nobody believed that, but now it appears that that's actually true. So the scaling is an important thing. But what I also see as a paradigm shift is that the skepticism in these models, or maybe I'd rather call it realism, is back again, and I find it healthy because now we can address those issues and can say, well, yeah, we know that, okay, machine learning is great and it has a great potential, but it is also risky if you are careless with how you use your data and how you do your training and how you do your deployment of your systems. And all of these things are now going hand in hand. So I would see the paradigm shifts is more at a meta level than at a technical level. And that's nice. That's nice because that's really necessary to put those things in a broader set of applicability compared to what we have been able to do so far. I would almost say, ask you, give me 5 examples of where machine learning is used in things that you know of, and don't come with voice recognition on your mobile phone, because we all know that one, and a few image recognition things, right, running with in the GAFA tools, but otherwise there's not so much out there.
Let's look at 3 machine learning topics or approaches that you have realized in your lab. Can you mention 3 approaches you're working on?
Yeah, so one thing we have been pioneering is latent state space models starting 2015 or 16. And latent state space models, and that's a term that most of the listeners will not grasp. So those are models that transform a sequence of observations into some internal representation in the system that is sort of extracts the physics. And now they still will not understand that. So let me try again. If I have a movie of something, some object flying around or so, I'm not interested in how those pixels change. I can't use the change of that pixel in that movie in order to predict where this ball, for instance, is flying. Instead, what I need to do is I need to extract the position of the ball out of the image, then use Newtonian equations to predict where the ball is going, and then use that prediction to then generate an image again 1 second from now. Right? That's how an engineer would do it. Now, the models we have devised can do that automatically without explicitly knowing the physics, but by just observing those pictures, by compacting it according to some probabilistic rules and methods, internal representation, which I would almost say represent the physics. It's of course not the real physics, right? It's not real positions in Cartesian space and velocities and stuff like that, but it is something which is very close to that, which exactly looks like that and can use.
How do you do that?
I would refer the listener to a paper that we published now. So how do you do that is by saying, well, I want to write a compact version of those pixels, and I can do that with a neural network, that compacting, which adheres to two things. First of all, I want each of the dimensions of my compact representation. So let's say I put it in a three-dimensional space. I want them to be independent of the others. So I want to have the principal directions of movement that can describe my image. And secondly, I want to ensure that I know the rule which brings my system from one observation to the next. And if I, for instance, well, I can say, well, this rule needs to be a Newtonian equation of physics, then that will come out of that. But I can also just say, well, it needs to be linear. And if it's linear, then I can still put those equations of motion, extract them from there. It's a very general rule to say it needs to be linear. And once I do have those two requirements, then I can learn to extract from an image, from a sequence of images, something like the physics of movement. And we've done that for drones. We've done that to learn maps of the environment. We have done that indeed for energy optimal control of air pressure in a plant at Wolfsburg.
Can I ask you one, maybe for a quick note on this one, Patrick? Would you allow me to make a comparison if I hear the word latent and I hear the way you explain is like you're looking at different states, time series, millisecond 1 to millisecond 2 or whatever, and what has changed, and you extract, if I understand correctly, physical information. Would you allow me to make a comparison or see a similarity in the two gentlemen we just talked about, LSTM, and then the M of the memory, which is what they included 25 years ago to say we need a piece of memory. We need the algorithm to understand what was there before, so we can then understand. Is that in another way, I assume, but something you do as well in a different way?
No, it's. LSTM is also one way of doing time series modeling in a recurrent neural network, but it does it totally different. It doesn't use this internal latent representation. So what we do is we explicitly map a sequence of observations, so the set of images, a movie, on a sequence of internal representations. And those internal representations we shape according to what we want. For instance, we can shape them as a linear space, or can shape them without any form, or I can shape them with the equations of motions of a drone, or I'm just giving examples that I'm.
Yeah.
So that's totally different.
Right. The suggestion was not that the way of doing things, but it was more at a higher level. I thought to recognize the similarity, the importance of time series, as which is what we've been talking about. Understanding the different state in which the world, the world around us is in from 1 millisecond to another one. And, that's what Sepp and Jürgen, looked at, and applications are somewhere doing it their way. That was not my point. And you, it is my understanding, also deal with that fact of looking at different states and what is happening between the different states around us.
I'll give you one more important difference, and that is that our system uses unsupervised learning.
Okay.
Whereas an LSTM or a recurrent neural network needs supervised learning. That is, I have a sequence of inputs and I map that to a sequence of outputs. In our system, I only have a sequence of inputs. And from that, I try to explain future states. So the second one is where we use similar models to create a probabilistic description of a system in a physical map. And again, I need to make that palatable, what I just said. Suppose I have an autonomous vehicle or autonomous robot driving around in a building, and that thing has a number of cameras. And indeed, now how can you learn SLAM from that? There are ways of doing that, right? SLAM is something that has been around for a few decades, but the only thing that SLAM does is, first of all, create a map of your environment, and secondly, gives you information on your position in that map, both at the same time, right? That's what it stands for, simultaneous localization and mapping. And we have taken that idea and put that in our probabilistic latent state space models and say, well, let's now take these models that I described before and not learn the dynamics of some kind of a robot or something like that, but let it instead learn a map of the environment. And of course, then you have some different structure, right? Like it's a 3D space and things like that. But what you now can do is I don't just have SLAM, but I have a probabilistic SLAM, meaning that I don't just have the position of the state of my agent, of my robot in my environment, but I have that as a probability density, and that allows me then to not just create SLAM, create a map and create a position on that map, but I can also use that to do control in that map. So I have now a fully closed system where I can do learning of the map, I can get my position, but I can also do control, I can do optimal exploration and optimal navigation in that map, all of that for the price of one. And that's something we've been working on for a few years, and that works even in real time right now. Real time in our vocabulary means at 10 hertz. So we can learn the map 10 images per second, real time on a normal computer.
Patrick, in general, what do you do with those kind of developments? Keep them for you, because you have paid for them, or, you understand?
So this thing started as a discussion I had with one of my employees, and he said, well, we have these models, what can we do with them? Well, I said, well, let's see if we can do SLAM with that. And he said, I take that challenge. And I'm ready in 3 months, he said. That was 3 years ago. So it was a bit more complex than we thought. But now that we have this running, we suddenly find that within the company, there are applications for this. For instance, creating a daily map of a factory floor, allowing you to find back objects, but also to do cleaning and to do navigation and bringing tools around and so on and so forth. What you also can do is use that to do maintenance. So you can go around a factory floor and find areas where problems arise because something suddenly sounds different or looks different than it did yesterday.
Right. So are you ready to make this available to outside of Volkswagen as well? So,
we open source, yes. So.
Okay, very good, very good. So maybe your view on that then is that changing the world. Robert has a separate podcast in open source, and I am of the area. Well, maybe not that very much different from you, but I always need I always need a push into the area. Not saying this is not good. I'm always looking at the implications. I was part myself maybe 5 years ago in a company where I was, and this is about OPC, it's about data, maybe you know about it, but it's not important. And from one day to the other, the organization decided we're going to make it open source. So there's a company making money with providing tools. That's changing from one day to the other. And I always need, Robert to explain, not to explain me, but to guide me in this complete new way of thinking that, software is supposed to be not free as in a free beer, but I'm interested in your view as a developer, as a scientist of algorithms.
So let's start in the other way around. First of all, I understand that patents are important for companies because it gives a enumeration of your investment in R&D, right? And it gives you some competitive advantage. And if you don't do that, then all of the investment that you do in R&D is open for grabs for your competitors, and it makes no sense to invest in that. So yes, exactly. So I understand that part. But once it comes to fundamental research and the difference between fundamental and applied research that's a podcast in itself, what that means. So let's not get down that. But once you talk about very principled methodologies, which are really not close to an application or not intended for an application on the very short term, once you do a patent there, then you stifle development. And I think that's especially true if you look at universities, right? If universities or public research institutions, if they try to earn their money by patenting, they are actually hurting themselves quite strongly, because that will prevent others from taking up that research and making it into applications. So, and now machine learning is I think, an excellent example where sharing code and data does making research comparable, which was especially true, I don't know, say in the period between 2006 and maybe 10 years ago or so, or 2015. It's a bit less now, but back then it was very important that if you share your data and you share your code, then you can have others compare their methods with yours and their results with yours. If you don't do that, then everybody just publish something and say, well, this is a great thing, but I don't know if it's better than the other because there's no way of comparing that. That's the typical case that you have in robotics research, right? That's why I think one of the reasons why robotics research is going so much slower than machine learning research, at least in the past decades, because you don't have this common ground and this comparability. So if you want to advance your work, and if you want to make sure that your work is understood by others and also others can improve on your work, then you have to share it. If you don't do that, well, then you can certainly do some research and so on. But you have no idea. You will certainly not get as excellent as the other ones. You can only do that as a community.
We will convince Peter. We will convince him.
Oh yeah. It's not about convincing. It's just about understanding. Yeah. So you say you still need to do your research. It's not like, let's say VW, BMW, Mercedes, a couple of other global car brand manufacturers. You cannot say I just stop doing my research. I just see what the others do. They open source and I take it. I just put it as bluntly like that. That's no way forward, right? You still need to do your own work.
Well, you can't just download a library and use it and then be happy with it, right? And even that requires a tremendous amount of expertise because the algorithm itself is just an algorithm and it's not a system.
So let's switch to the third approach because we are running out of time.
The third approach that I'm very proud of, and that's one that will surprise you, is my initiative in ethical and trustworthy AI. So I told you, right? I started with neural networks in the 1980s, in the 1986 or 7 or so, something like that. And that means that I also went through one of those AI winters, which I would say started in about 1995, or was it 2, somewhere like that. somewhere there, around those times. I think it was 1995 when support vector machines then became large and everybody loved them. And then neural networks were dead and we were all depressed and started doing something else. And I don't want to be there again. So when I started working at Volkswagen, and now it's a bit later, end of 2017 or so, I saw initiatives like PI, the Partnership on AI. And this is an initiative started by, Facebook, Apple, Amazon, IBM, companies like that. Probably Google was there as well. I don't remember exactly. And what they did back then is say, well, we as list of companies will only use AI for good, and we will ensure that no people are harmed, and so on and so forth. You can write a whole codex of good intentions, and of course there are good intentions, but that doesn't mean that you can actually do that, because as a programmer or as a researcher or as a developer, the fact that I don't want to have bias in my algorithm, what does it mean in how I train my neural network? There is no way to translate such a code of conduct to actionable items. So I first thought of joining PI as Volkswagen, and I talked to them, and then I found their conditions ridiculous, and actually I didn't like how to do it, so I said, well, I can do this better myself. So I started an initiative. It's called etami, which is now a large initiative. Started off as 17 companies. We're now growing into 100 companies, and not just companies, also research institutions, of course, universities and research centers, where we develop processes and tools in order to create transparency and quality, mostly, into the development of machine learning software and applications. So prevent a situation where you say, well, okay, I've got my data set, I trained my neural network, I got 0.4 as an answer, and I think that's quite excellent. Let's put this thing in production. And I know that's still being done, and we all know that that's not how you should do it. So what we do is create methodologies to do data, not just curation, but data logging, data understanding, of course, also model and training quality and logging and documentation, but also understand how deployment of these models must be done in order to be able to react when a system does something stupid, which they always will, of course, but you need to detect it and then repair it. So create a whole quality process from the idea of a system you want to make up to its final deployment, so that people, including myself, have trust in what's out there.
When I talk to some big industrial players, and then sometimes they say, is it not also an idea to protect the market, because industrial companies are used to norms, etc., etc., and it's not only about trustworthy and also to protect the market for European companies?
No, I don't see that.
Okay.
You mean protect against whom? What do you mean exactly?
Protect against big tech software companies who are not familiar to use the norms, etc., etc.
No, it's really about creating methodologies that I, as an end user, can trust and feel safe with. That's what it is about.
Okay.
Yeah, of course, those big companies, they are heavily impacted by these, but not just those, right? Just as well, any company here in Europe which uses.
Yeah, sure, but for them that's common that there is a norm and there's a regulation on stuff like that. And I think sometimes it's a little bit, only maybe 5%, they are happy because it's also protecting the market, I think.
I think that Google and Amazon, all the other ones, have as many people in Brussels, like probably VW or SAP or whoever.
Absolutely.
Patrick, if I may, we are in strong agreement, me as well personally, for many, many years regarding trustworthy AI. So I assume you're looking forward to the EU AI Act. You already mentioned the EU Data Act. What I just heard from you explaining, is that kind of, you're ready, you're prepared for, or are they, if you say ML ops and stuff like that, does it go a lot further, a lot more detail than what the EU AI Act is actually going to be expecting from a company like VW and all the other ones?
So first of all, certainly not ready, right? The AI Act is the Parliament is going to vote in early March, and then we expect the regulation to be finished by the end of 23, and then it will not be into force until beginning 26. So there's still some time. The fact that we know to a large part of what is going to be in there doesn't mean that it's easy to comply by it, and that's work that is I took on myself, and I'm responsible for that topic in Volkswagen currently. Be careful what you wish for, right, in your life, but there you go. And yes, certainly we are going to go further than just adhere by this AI Act, and we're certainly also going to look into the gray zone of ethical implications where you can. And we actually have or are in the process of developing an ethical codex for Volkswagen AI as well. That takes a while because you have to get all parties of such a huge company on board. That's always a bit tricky, but that's coming. And of course, there's nothing out of the normal in that ethical codex there. It's very similar to all the other ones. But we will ensure that we will try to adhere by these ethical codices, also by the high-level expert group on AI and the OECD one and the United Nations, UNEC one, not UNEC, the other one, I always forget that. And of course, then by the AI Act. But of course, there are also similar legislative frameworks in other countries in the world, right? And we also have to abide by these if we put our products somewhere else on the market. So that's a nice challenge.
That's a topic in itself, right? I mean, that's where I'm closer to you, Robert, where you say, sure, I mean, different parts of the world, different norms, sometimes we'd like to be, and we work together on technical norms all the time, China, United States, Europe, everybody, and many, many, many times agree on technical norms. If we come to norms of trustworthiness, of course, we do not always agree.
But also the US has norms, right? I mean, it's not that it's a lawless country.
No, but different norms. If we talk about right, so right, then the expectation is that if you're gonna put your cars on the Chinese market, then I don't know what your ethical norms are gonna be talking about, and then you get into politics and all kind. I mean, the point is you cannot have one set of ethical guidelines for the world, right? Because the world is not that agreed upon what norms or what ethics to use.
Absolutely right, and that's a fascinating discussion, which I would love to join, but I'm sure one wouldn't come to an answer. Yeah, and I mean, we actually I had a very interesting call with people from Volkswagen Nutzfahrzeuge in Hanover recently on the ethics of autonomous driving, and I know nothing about autonomous driving, and I know nothing about ethics. But
why they call you?
Well, because I say
number.
those words all the time. Okay. No, but it's fascinating because you get into ethics like, okay, what about animal life, right? So how do you discern that? And there are societies where crabs are listed as sentient animals. So do you drive over a school of crabs if you avoid la-di-da, so you get this. It's very interesting stuff, and there are certainly some technical ways about that, but you shouldn't start solving ethical questions as a technical company. You should address them, but you shouldn't answer those.
So what are your plans for the coming year?
This year, we have a crisis on our hands, right? A global crisis. And that puts forth some fascinating, not just financial challenges, but certainly also financial challenges, which we need to address. One of my big things for the next year is to make this association that I mentioned, etami, I call it, on ethical and trustworthy AI, make that fly and make that really large. I'm also going a bit stronger into deployment of the methodologies that we have been developing in the last 6 years. So slowly building that up. And at the same time, have my fun with the administration of a company with 600,000 employees.
Okay, perfect. We wish you all the best. Patrick, it was a pleasure to talk to you. Thank you very much.
Thank you very much for this interview.
Thank you, Patrick. Have a great day. Bye-bye.
Bye.